Hi, my name is Dan, and this video is one in a short series of videos about using vectors in Unreal. And in this one, I'm going to focus on the use of forces. So you might have heard of forces in physics or in science in school. You've heard of the Force in Star Wars. It's not quite like that, but we're going to dig into applying forces to something. So the setup that I've got here is a standard third-person template setup, and I've got a few things in here that we need to look at. So the first thing is I've set up some control in the project settings. I have added 6 new controls, which are up, down, left, right, forwards and back, and I've just mapped them to R, Y, F, H, T, and G. It's a bit like WASD, but a little bit further over to the right, because WAS, AS and D are being used. And then I have this blueprint here. Actually, before I show you that, I'll show you the roof. Very proud of my roof. We're going to need a roof because we're going to be flying this box all over the place, and it's quite easy to lose it outside our little level if we don't cap it off. So inside here, I've got a few things set up here. So the first thing is that it's enabled, inputs been labeled, so that it can get some stuff in. I have got 6 Boolean variables, count them down here, use up, use down, etc. And these are going to be toggled so they switch on whilst you're holding a particular key, and when you let go, it will switch the Boolean off again. So I've just got all those set up as well. So action up, it toggles use up, and then when you let go, use up is set to false again. And that's done for all 6 of the controls, so that we've got the 6 booleans there. And then in event tick, I've got a sequence. So I've just got 6 little sequences, and each one of these is a branch which is testing use up. So what's going to happen is, as event tick happens, which is every frame, it will check which of these keys are being held down by using these booleans, and for those that are, it is going to do something. And so we have 6 outputs here that we can use to do. Right, now you may have heard that force equals mass times acceleration. That's one of Newton's laws. Let me show you my box. So my box is floating in midair. Actually, I should have shown you that inside the design of this. It's just a cube. I've stuck a texture on it just for the fun of it. And down here I have clicked simulate physics is selected, but enable gravity is disabled, so it's floating in midair. But it's not fixed because if I bump into it, it'll move. So the physics simulation is working, and I can make it bounce around, but it's quite easy to get it out of reach so that I can't actually do much with it. What I'm going to do is I'm going to use these keys that I've set up to apply different forces in different directions to this cube. So let's go back into here. Now, as you might imagine, because this is a series on vectors, a force is a vector, and so it's got an amount, which is the amount of push, and it's got a direction, which is the direction that it's being pushed in. And a force is, you can think of it as being a push. So if you were standing here next to me and I started pushing against your shoulder, trying to push you over, which wouldn't be a very nice thing for me to do, that would be a force that I'd be applying to you. And the force that we're all aware of that's around us all the time is gravity, which pulls us, think of it as a pull, but it pulls us towards the centre of the earth. So forces you can think of as pushes and pulls. And a vector that's a force will always show you the direction that that you are being pulled or pushed, or whatever the object is. So, in order to apply some forces, we need the nodes add force, and that's automatically selected for cube, which is the part of the blueprint which has got physics enabled on it. So it's been clever enough to work out that we're going to want to apply it to this cube. I'm going to replicate that. I should have replicated the other thing as well, but we'll do that in a second. Right, so I need to replicate the cube. Just look at that in. One of the reasons why I do so much setup for these videos is so that you don't spend all your time watching me plugging things together when it's not of particular interest to the actual topic that I'm dealing with. So I'm going to make these happen. This is quite a normal thing to do when size is an issue, is to do this staggering. Here we go. So we've got, for each one, use up, but all the forces at the moment, the vectors are set to 0. So up is positive Z, and I'm going to put 10,000 in here. Now, forces in Unreal, the numbers always seem to be bigger than you think they should be. Minus 10,000. And the reason for this is that Unreal uses centimeters instead of meters, and so any measures that are dependent on length in any way will have at least a factor of 100 in there that you might not expect, and maybe more than that. What am I doing? Yes, so left is minus 10,000 in the Y. That's not 10,000, that's 1,000. Right is 10,000. And what have we got? We've got forwards, which is X. And negative X. That was right. So let's go look at this. So here's our cube. I'm going to press play. And when I press, you can't see my fingers, but when I press the Y key, this should make force this cube downwards. There we go. It's actually quite a light force. 10,000 seems like a big number, but this is a fairly light force. And now I'm pressing the key to make it go upwards. So as I was saying before, force equals mass times acceleration. So what's actually happening here, because the physics is enabled, the forces apply on the object and they accelerate the object. And the physics simulation also has some measure of bouncing built in to this. So when it reaches the top, it bounces. Now I'm going to take it sideways. Let's bring it to the bottom. So everything's a bit sluggish. It's like I'm kind of moving it through some kind of soft treacle, or as if this is a balloon, maybe. I wanted it to catch the edge there. There we are, we're having it bounce off there. And it's still subject to other collisions, like with the player. Oh, I can't reach it. It's so tempting to spend ages playing with this. There we go. Just because it's kind of fun. So there are a couple of things that I wanted to demonstrate with this. I'm just going to stop and start again so that I've got my cube in a handy position. So I'm going to press 2 keys at once. I'm going to press the up and down key at the same time. And as you might imagine, nothing's actually happening. If I let go of one briefly, then I've given a small upwards force there for a small amount of time. But as I'm pressing both keys, two forces are being applied, one up, one down, and those two forces are cancelling each other out. Now, if I press, just go bring it down a bit, there we go. If I press forwards and left at the same time, you can see it's, again, as you might expect, going in a diagonal direction. When you describe forces with vectors, there can be any number of forces acting on an object, but you can simply add them all together by effectively using vector addition by putting them end to end. And that gives you the resultant vector is what's called the net force, which is the final amount of force that's being applied in a particular direction on that object. And physicists who deal with mechanics do that sort of calculation all the time. But Unreal, of course, is doing all that stuff for us. Let's bring it down. So vectors are a great way of dealing with forces. I'm just going to make a little change now in here, which is I'm going to make this work like gravity. And in fact, gravity is just a downwards force. So this is what we want. And I've done a little bit of experimentation, and it's 98,000, or minus 98,000 is gravity. Let's see if that looks realistic. Let's apply it. Let's zoom. Pull it up. That's actually quite strong. Maybe I'll put an extra 0 in there. I need to check that, but I'll go back to that. So now, if I press the R key and the Y key at the same time, let's make it gold first, otherwise you can't see anything happening. Then the force, the gravitational force, which is the downwards force, will overwhelm the upwards force. The resultant force, which is the sum of both of them, is actually still quite a lot of downwards. Right. So first I'm going to double check that. I think I put an extra 0 in there. I have. I made that 980,000, which was 10 times gravity. No wonder it looked a bit odd. Let's go back in, and that looks a little bit better. Balance those two out, get it floating. I'm going to jump up and then pull down the gravity on my box and fall. I can't tell whether it's the same rate or not. And of course, the other forces still work. In fact, I'm going to now go back in and make a little change, which is to change all of these to that size, so that we can make it look as if gravity is moving round for the box onto different surfaces. Just 2 bags in there. 1,000 minus 98,000. 98,000. Okay, here we are. Press a key there, it's falling down, and now gravity switched to upwards. Yep, but only for the box. Gravity's that way instead. Oh no, suddenly gravity's backwards, sideways. Press several at once and see what happens. And we'll throw that box around like all sorts of things. I'll do another quick thing, which is to actually make it so that we don't have to hold a key for gravity to work. Gravity is going to be permanently on. So that's easy enough to do, actually, because we've just got this Boolean used down, and I'm going to set that to true, and then disconnect the toggling of that. So it's not possible for us to switch it off. And that gravity is now acting all the time on this box. We can, again, still move it around. And this is how you could, I know Unreal does its own physics simulation, but this is how you could do a start on your own physics simulation if you wanted different things from the way that Unreal does it. I'm going to have to apply the upward force to make it move because it's pulling too much downwards at the moment. I got in the way. Right, so I'm going up and pushing sideways. So the up force I'm doing is counteracting the standard gravity. I'll just let go there. It doesn't actually pull it up because it just balances against it. But if you press other things, it means that it doesn't pull so hard and lock it to the floor. There we go. Right. I'm just going to show you one more thing, which is in physics that we've dealt with forces. There is another way of doing forces. Something that I've skimmed over in this video is that you have to keep the key pressed to keep the force working. Now, this is fine for forces that are continually applied, but what if you just want to give something a big belt and to get it working? Sorry, I'm not going to do that. And in physics, this is called an impulse, which is a force that acts very strongly, but only for a short amount of time. So I'm going to just take off all these. So an impulse only has to happen once. It doesn't have to happen continually. And it's like the box is being punched by something or hit or had a collision of some kind. And that's imparted a large amount of force over a very short period of time, but it has had an effect on it on the physics simulation. So add impulse. Right. So we'll copy that and paste, rearrangement. We've done 1, 2, 3, 1, 2, 3, 4, 5. Let's say quarter for 5. There we go. And you're probably getting quite used to doing blueprint scripting for yourself by now, and you're probably used to the fact that while on the face of it, the wires and the nodes are quite simple and straightforward, having to rearrange things to make things line up is a little bit of a pain. So we're going to apply impulses, input action up. So that needs to be positive Z. And what I'm going to do is I'm going to multiply by 10 again, so 980,000. Because it only acts for a short period of time. Left is -1. False. Right, let's see this in action. So he was back where it was, and I'm going to press which key should I press? The Y key to go up. Ooh, the Y key to go down. I bounced it off the floor. I was pushing it upwards. That's quite a lot of impulse that I've got there. Yes, it's huge. That's nice. It was a lot of fun. And that has actually gone so fast that it's gone through the wall because the physics detection isn't fast enough and it just flipped through. So my 980,000 was too much in the circumstances. Oh my goodness. Yes, that's huge. Back. I now got the immediate curiosity of what happens if I put the character in the way. Oh, it just bounces off. So that's how to apply forces and how to apply impulses using the physics in Unreal, and both impulses and forces are vectors. And that's it from me for now.